All right, welcome everyone. Today, we're going to talk about how to architect a truly rock-solid ML-ready data foundation, specifically on Google Cloud. If you've ever watched a really promising AI project just stall, or if you've been wondering how to actually unlock the potential you know is there, then yeah, you're in the right place. So here's our game plan. We're going to trace the whole journey of data from raw and messy all the way to AI ready. We'll kick things off with a big one, the ML data challenge itself. Then we'll get into building that solid foundation. After that, it's all about turning data into features. We'll also tackle the tricky offline versus online worlds, make sure we cover trustworthy AI, and wrap it all up with some real actionable blueprints for success. Okay, so let's just dive right in with a question that I'm willing to bet keeps a lot of you up at night. Why? Why do so many data science projects, the ones with huge potential, with brilliant people working on them, why do they just never make it to production? The number is, well, it's pretty staggering. We're talking as high as 87%. Just let that sink in for a second. 87%. That's almost 9 out of 10 projects that fail to deliver any real business value. Think of the wasted time, the effort, the money. It's just a huge problem. So what's the deal? What's the main reason for this massive failure rate? Well, 9 times out of 10, it starts and it ends with one thing: the data. You can have the most brilliant model, a truly genius algorithm, but it is completely, utterly useless if it's built on a shaky, inconsistent, and untrustworthy data foundation. And that right there, that's the heart of it. That brings us to our first big topic, the ML data challenge. Let's call it the quest. All right, so how do we actually conquer this quest? Well, that takes us to part 2, forging the foundation. The whole solution really starts with creating a single, reliable source of truth for all your data. And listen, this isn't just about picking a database. This is the absolute bedrock of your entire AI strategy. And this is a great way to visualize that whole process of data maturation. Look, you start by just ingesting all that raw, messy data into some kind of landing zone. Step 1. From there, you get to work. You cleanse it, you deduplicate it, you transform it into what we call processed data. But the final and honestly most critical step is creating those curated, feature-engineered datasets, maybe in a tool like BigQuery. These are your gold standard assets. This is the stuff that's actually ready for your ML pipelines. Okay, awesome. So we've got this beautiful, pristine, curated data. Now what? How do we actually turn it into the powerful signals our AI can use? Well, that brings us right into section 3. The training grounds. And here, we're going to talk about tools like Vertex AI and this really vital concept of a feature store. So what in the world is a feature store? I love this analogy. Think of it like a specialized armory. It's this centralized, super well-managed repository that's built for one thing: to store, share, and serve up machine learning features. These are the weapons your models are going to use to make predictions. Okay, but why does this matter so much? This is the important part. First off, reusability. Your data scientists are not wasting precious time recreating the same features over and over again for different projects. Huge win. Second, and this one is absolutely crucial, consistency. A feature store solves that dreaded training serving skew. Where your model behaves differently in production than it did in training? This makes sure the exact same feature logic is used for both training and serving live predictions. It's a game changer. And third, discovery. It just helps teams work together, letting them find and use features that someone else has already built and validated. And that whole idea of consistency, it leads us perfectly into our next section, what I call the 2 fronts. Because look, every single production ML system has to fight a war on 2 different battlegrounds at the same time. There's the offline world of training, and then there's the online world of real-time serving. Let's use a classic example, fraud detection, to really break this down. So here's the breakdown. On one hand, you have the offline training world. Here, you are dealing with massive volumes of historical data. We're talking terabytes, petabytes. Latency? Not really a big deal. A training job can take hours, even days. All you care about is getting the most accurate model possible. But then, you have the online serving world, and it's a completely different ballgame. Here, you're looking at a single event, one credit card swipe, and you need a prediction in milliseconds. The goal is an instant, super low latency decision. Your architecture has to be able to handle both of these worlds perfectly, without any compromises. Okay, so having a model that's fast and accurate is great, but it's meaningless if you can't trust it. And that brings us to the laws of the land. We're talking about the essential governance you need to build in to make sure your AI is reliable, ethical, and just plain trustworthy. We've all heard that old saying, garbage in, garbage out, right? Well, in the world of AI, it's actually way more dangerous than that. It's garbage in, gospel out. Think about it. An AI model will take bad data and confidently spit out a wrong answer, and the business is going to treat that answer like it's the absolute truth. That can lead to some seriously disastrous consequences. So, to stop that from happening, every architect, every single one, has to build these 3 pillars into their platform. First, data quality. We're talking rigorous checks to make sure your data is accurate, complete, consistent. Second, data lineage. You need to be able to track every single piece of data from where it was born all the way through every transformation it undergoes. And finally, reproducibility. This is the ability to perfectly recreate any ML experiment and its results. For things like debugging or regulatory compliance, this is totally non-negotiable. Okay, let's bring this all home. In our final section, we've got the blueprints for success. Think of this as your map, giving you some really actionable architectural patterns that you can start thinking about, as soon as we're done here. So here are the absolute key takeaways for your architecture. Rule number 1, centralize your curated ML-ready data in something like BigQuery. Make that your single source of truth. Rule number 2, you have to use a feature store, like the one in Vertex AI, to nail that consistency between training and serving. Third, automate your training pipelines. Use tools like Vertex AI pipelines to lock in reproducibility. And last but definitely not least, do not treat governance as an afterthought. You have to implement robust data quality and lineage tracking from the very beginning, from day one. And that really brings us to the end. So I just want to leave you with one final question to think about. I want you to take a hard, honest look at your current systems and ask yourself, is our data architecture a true enabler for AI innovation? Or is it the silent blocker that's keeping our projects from being part of that successful 13%?